Example, we want to use the alternating series test to determine convergence or divergence of the sum from n equals 1 to infinity of cosine of n times pi divided by n squared. So let's write out a few of these terms first. We have, substituting n equals 1, cosine of pi divided by 1 squared plus cosine of 2 pi divided by 2 squared plus the cosine of 3 pi over 3 squared plus the cosine of 4 pi over 4 squared, and so forth. Well, the cosine of pi is -1. The cosine of 2 pi, if we think about this, brings us back to 1. So we have a -1 over 1 squared plus 1 over 2 squared. Cosine of 3 pi is -1, so plus -1 over 3 squared. Cosine of 4 pi is +1. So we have a 1 over 4 squared, and so forth. So we can indeed view this as the sum from n equals 1 to infinity of -1. We're starting at an odd power, or we're starting at a negative, so we want this to be -1 to an odd value, which is just n, times 1 over n squared. And it's this 1 over n squared that will be our a sub n. Clearly, a sub n is indeed positive. We can take the limit as n goes to infinity of a sub n equals the limit as n goes to infinity of 1 over n squared. And when we send n to infinity, n squared also goes to infinity. So this is 1 over infinity, which is 0, and the limit. And then we want also for a sub n plus 1 to be less than or equal to a sub n. Well, if we think about this, we know that n plus 1 is greater than or equal to n, always. In fact, it's greater than n. We don't even have an equal sign here. So what that means is that 1 over, before we go to that, and this is positive. So that means that n plus 1 squared is greater than n squared, which also implies that 1 over n plus 1 squared is less than 1 over n squared. That is, a sub n plus 1 is less than a sub n. So, by the alternating series test, since the limit of a sub n goes to 0 and a sub n plus 1 is less than a sub n, we can conclude that the sum of cosine of n pi over n squared converges.